Good morning to everyone. I am Dr. Sumi MS. The name of the course is Electromagnetic Fields and today's lecture topic is Divergence Theorem. On completion, the students will be able to understand about Divergence Theorem and obtain the mathematical equation of Divergence Theorem. The Divergence Theorem relates an integral over a volume to an integral over the surface bounding that volume. This is useful in a number of situations that arise in electromagnetic analysis. Let's consider a vector field that is being representing a flux density such as the electric flux density or a magnetic flux density. The divergence of A is given as del dot A is equivalent to F, where F of R is the flux per unit volume through an infinitesimally small closed surface surrounding the point at R. Since F is flux per unit volume, we can obtain the flux for any larger contiguous volume V by integrating F over V, and this flux through volume V is given as integral over V F dV. In the Cartesian system, V can be interpreted as a three-dimensional grid of infinitesimally small cubes having side lengths dx, dy and dz respectively. Note that the flux out of any face of one of these cubes is equal to the flux into the cube that is adjacent through that face. That is, the portion of the total flux that flows between the cubes cancels when they are added together. In fact, the only fluxes which do not cancel in the integration over V are those corresponding to the faces which lie on the bounding surface. Yes, since the integration stops there. Stating this mathematically, we get the volume integral over F dV is equal to a closed surface integral over A ds. Thus, we have converted a volume integral into a surface integral. To obtain the divergence theorem integrating both sides of that equation over V, we can get integral del dot A dV is equal to integral F dV. Now, applying the surface integral to the right hand side, we get integral del dot A over V dV is equal to surface integral over S A dot ds. The divergence theorem states that the integral of the divergence of a vector field over a volume is equal to the flux of that field through the surface bounding that volume. The principal utility of this divergence theorem is to convert problems that are defined in terms of quantities known throughout a volume into problems that are defined in terms of quantities known over the bounding surface and vice versa. Quiz questions on divergence theorem. What is divergence theorem? Where is divergence theorem applied? Thank you.